The periodic table, also known as the periodic table of the elements, is an ordered arrangement of the chemical elements into rows, periods, and columns, groups. It is an icon of chemistry and is widely used in physics and other sciences. It is a depiction of the periodic law, which states that when the elements are arranged in order of their atomic numbers, an approximate recurrence of their properties is evident. The table is divided into 4 roughly rectangular areas called blocks. Elements in the same group tend to show similar chemical characteristics. Vertical, horizontal, and diagonal trends characterize the periodic table. Metallic character increases going down a group and decreases from left to right across a period. Non-metallic character increases going from the bottom left of the periodic table to the top right. The first periodic table to become generally accepted was that of the Russian chemist Dmitry Mendeleev in 1869. He formulated the periodic law as a dependence of chemical properties on atomic mass. As not all elements were then known, there were gaps in his periodic table, and Mendeleev successfully used the periodic law to predict some properties of some of the missing elements. The periodic law was recognized as a fundamental discovery in the late 19th century. It was explained early in the 20th century, with the discovery of atomic numbers and associated pioneering work in quantum mechanics, both ideas serving to illuminate the internal structure of the atom. A recognizably modern form of the table was reached in 1945 with Glenn T. Seaborg's discovery that the actinides were in fact F-block rather than D-block elements. The periodic table and law are now a central and indispensable part of modern chemistry. A majority of the elements on the periodic table of elements categorize themselves as metals. On the periodic table, metals are placed to the left of the zigzag line that runs between the 5 elements: boron, silicon, arsenic, tellurium, and astatine. Elements that happen to fall on the line or just to the left of it: boron, silicon, germanium, arsenic, tellurium, antimony, and polonium, may be classified as metalloids or semimetals. This means that they have properties of both metals and non-metals. Non-metals account for a small portion of elements on the periodic table. On the periodic table, non-metals lie to the right of the zigzag line that runs between the elements boron, silicon, arsenic, tellurium, and astatine. Non-metals also include hydrogen, which lies to the left of the metalloids. Many of these elements have biological roles. Living things are made up of almost entirely non-metals like carbon or hydrogen. 1. Alkali metals. These include elements like lithium, Li, and sodium, Na. Alkali metals are highly reactive and are known for their tendency to form compounds with water. 2. Alkaline earth metals. Examples include beryllium, Be, and calcium, Ca. Alkaline earth metals are less reactive than alkali metals but still exhibit some reactivity. 3. Transition metals. This extensive group includes elements like iron, Fe, copper, Cu, and gold, Au. Transition metals are characterized by their variable oxidation states and their ability to form colorful compounds. 4. Lanthanides and actinides. These are the rows of elements below the main body of the periodic table. Lanthanides, from lanthanum La to lutetium Lu, and actinides, from actinium Ac to lawrencium Lr, are part of this group. They have unique properties and find applications in various fields. Thanks for watching.